Hello, math students. This is video 9C, and in this video, we're going to talk about the domain and range of a function. All right, so to begin with, we have a couple important definitions. Two we've seen already. A relation is just a set of ordered pairs, like any graph is a relation. All right, a function is a special one. A function is a relation where every input only has one output. All right. So, two new definitions we're going to give today. The first is domain. The domain is the set of inputs to a relation or function. These are the x values, while the range is the set of outputs that come out of the function or relation. These are the y values. Okay, so here's kind of a picture of it. We have a function here, and the numbers going into the function, that's the domain, the set of inputs, and the set of outputs are the numbers coming out of this. All right. Well, okay, so here we have a list of ordered pairs. It's one way of specifying a function, and we're supposed to find the domain. That's simply the x-coordinates, right? So a set is just a list of numbers. We're going to just list the x-coordinates. So okay, we're going to draw the fancy set brackets. And when we list the x-coordinates, we don't list any repeats. So we're just going to put 3 once and not the second 3. The other input that we have is 6, so I'm going to put a 6. And I already have a 6, so I'm not going to list that one again. A set is just a collection of objects, usually numbers, and you're either in it or you're not. All right? So, all right, the range, that's the set of outputs. Those are the y values. So the range of this one would be 9, -2, 1, and 3. Those are the y values. So the domain are the x values, the range are the set of y values. Now, is this a function? The answer is no, because there are some inputs that have more than one output. The input 3 has output 9, but see the input 3 also has an output -2, not a function. All right, let's take a look at this one. The domain is a set of x values. So we have 2, 5, 6, and 0. When we list the elements of a set, they don't have to be in any particular order, so it's okay that they're not in order. The range would be the set of y values. So we have a 9, a 4, a 2, and a 5. I believe this one is a function because every input gets used only once. Every input only has one output, so this one's a yes. Okay, tables make it really easy for us. The domain is a set of x values. So -4, -1, 3, and 6. There were no repeats. The range is a set of y values. 4, 1, 5, 9. Is it a function? Yep. No input got used more than once. All right, we have discrete points. So the x values of each of the points, that forms the domain. This point has x value 2, we have x value 3, this one has 4, x value 5, x value 6. So 4, 5, and 6. The range of the set of y values, we have a 2. This one has y value 4. This one has y value 6. The y value of this one is 4. That's already in the set, so I'm not going to list it again. And this one has y value 2, which is also in the set. Is this a function? Yes. Every input gets used only once. It passes the vertical line test. Any vertical line I draw crosses the graph at most once. So this is yes. All right. So here we have a function here. It says if the domain of G is -6, 0, 1. That means those are the 3 inputs. What's the range of G? We just got to find the 3 outputs. So we got to find G of -6, G of 0, and G of 1. Well, at negative 6, it'd be negative 6 squared plus 7 times negative 6 plus 12. That's 36 minus 42 is negative 6 plus 12, I think is 6. When we put in 0, that one's kind of nice. 0 squared plus 7 times 0 is 0, plus 12 is 12. And when we put in 1, we get 1 squared plus 7 times 1 plus 12. I think you get 20. So the range of this, the set of outputs would be 6, 12, and 20. All right. Now we want to move into finding the domain and range of continuous graphs, like this one. So, all right, let's want to think about reading the graphs first. So when the input is 2, that's right here, this is 2. The output, well, the output would be 3. So we start at 2, go up to the graph, and read off the y value. When the input is 4, well, we go over to 4, go up to the graph, read off the y value. That's equal to 3 also. At 6, we have a problem. There's no function there. So this is undefined. It means that 6 is not part of the domain. It's not an input to this function. If I put in 0, I have the same problem. If I go to 0, there's no graph there. This is undefined also. 0 is not an input to this function. There's no graph there. All right. So I want to think about what's the smallest value we could use. And it turns out it would be this value. 1 is the smallest input we can use. Anything to the left of that, there's no graph. The largest input we could use is 4. So it says we can say that the domain, the set of inputs, is everything from 1 up to 4. Okay, this are the values of x right here where there's a graph. All right, all these values of x have an output. That's the domain. X is greater than or equal to 1 and less than or equal to 4. All right, so I want to make sure I was in the right place here. We want to find the domain here. Well, the idea is how far to the left does the function go? We're thinking horizontally in the x values. The furthest x value to the left would belong to this point, which is 1. Now, how high does it go? How far to the right does it go? Well, the graph goes to this value of x, which is 7. So that's the domain. That's the set of inputs. And if I shade in this part of the number line, we see that use the value of x where I can find an output. All right, this one. How far left does it go? Well, it goes to x equals negative 6. How far right does it go? It goes to x equals 1. That's the domain. Everything in between negative 6, which is right here, and 1 has an output. All right. This is a discrete graph. When the graph is discrete, we're going to use set notation to list individual values of x. I'm just going to list the x coordinates of each point. The domain would be negative 2, negative 1, 0, 2, and 4. So individual points means individual values for the domain. This is back to being a continuous graph. We have a range or a whole interval of values. So we think, how far left does it go? This graph starts at negative 2. How far right does it go? It goes up to 6, 7, 8, up to 8. All right, so it would be these values. Okay. Now, we want to start talking about the outputs, the range. So if the output is negative 2, what was the input? Well, here's negative 2. Turns out that the input was 4. I'm just going backwards. I'm starting with the y value and finding the x value. If the input is negative 6, or I'm sorry, the output is negative 6, what was the input? It looks like the input was x equals 6. Is it possible to have an output equal to 5? Well, if I look up here, this y value, there's no graph for that y value. So no. That means that 5 is not in the range. It's not an output for this function. Okay, so what is the smallest output? How low does the graph go? Well, it goes down here. This is the smallest y value in the graph, and it would be -6. What's the largest possible output? That's how high does it go vertically. Well, it looks like the largest output is going to be 4. So we can have outputs. There's a graph for every value of y in between -6 and 4. And that's the range. That's the set of outputs. We have outputs from -6 to 4. And outside of those values, there's no graph. All right, so take a look at this one. If the output is 4, what's the input? Well, if the output's 4, it's actually two different inputs. We could have x equals 1, or we could have x equals 5. If the output is 1, what was the input? Okay, well, here's 1. So there are 2 points. It looks like x equals 2. And here's another one with output 1, or x equals 4. Is it possible to have an output equal to -1, which is here? And the answer is no. There's no graph there. -1 is not a possible output. -1 is not in the range. Okay, so it says, what is the smallest possible output? Well, right here. This point right here has y equal 0. What's the largest possible output? Well, these points. That's how high the function goes. Y equals 4. So the range would be y is greater than or equal to 0. And actually, there is a point with y equals 0 and less than or equal to 4. These are the possible outputs for this function. All right, a couple quick examples, and we finished it. For this graph, we want to know the domain. All right, so remember, how far left to how far right. Think horizontally. These are x values. Well, this graph starts at -4. It has a hollow dot. It means it actually doesn't include that point. So we're going to say x is greater than -4. I'm not going to put the equals there. And the highest value is 4, so less than or equal to 4. It has a solid dot, so there's an actual point with x equals 4. All right, the range, think how low it goes. It goes down to -5. It's a hollow dot there, so I'm not going to put it equals. Whoops. There we go. And we have y values that go up to this point, 0. Okay, so x values from -4 up to 4. And we got y values that go from -5 up to 0. So domain is how far left to how far right. Range is how far down to how far up. Last one here, the domain. Well, this function, the furthest point to the left is -5. Furthest point to the right is 3. So we're going to say -5 is less than x is less than 3. They both have hollow dots, doesn't include those points, right? So I didn't put an equals under the inequality. And how low does it go? Well, this graph goes from -4 and all the way up to 2. And there is an actual point that does have a y value 2. So I'm going to say less than or equal to 2. All right, so that's the range of x values, and this is the range of y values. Okay, well, that's an introduction to domain and range. Takes some getting used to, but you'll be fine at it. Here's the journal assignment. Go ahead and do these. The first graph is a discrete graph. The second graph is a continuous graph. Find the domain and the range.